Hello guys, my name is Vlada, and in this video we will do similar problem like in the previous video, just as I promised to you. So we will third problem, we will integrate over the curve L scalar field x plus y, where L is straight line from the point B, which has coordinates 3, 4, to the point A, which has coordinates 0, 0. So I owe you a picture from the previous video. This was the situation in previous video. We started from the point A and we were going in this way, and our last point was B. So this was situation from the previous video, and in this video situation is reversed. We are starting from the point B and we are going in this way, finishing in the point A. So the question is which result we will get. In the previous video we got a result 35 halves, this vid, and in this video we will get the same result, and I will show you that. So let's start. Our first step will be to parameterize straight line from the point B to the point A. Let's just remind ourselves what is the equation of straight line from one point to other. Okay, and here we have y minus y1 over y2 minus y1 is equal to t, where t goes from 0 to 1. In this example, our first point, our starting point is B with coordinates 3, 4. So B is a point with coordinates x1, y1. x1 is equal to 3 and y1 is equal to 4. And our finishing point is A with coordinates x2 and y2, so x2 is equal to 0 and y2 is equal to 0. Okay, let's plug in this values. Here we have x minus 3 over 0 minus 3, that is equal to y minus y1 is equal to 4 over 0 minus 4, and that's equal to t, where t goes from 0 to 1. So this will be the range of t. Okay, from this we get that x minus 3 over minus 3 is equal to t, so x will be minus 3 times t plus 3. So this is the parameterization of the variable x. And from this we get that y minus 4 over minus 4 is equal to t, so y will be equal to minus 4 times t plus 4. So this will be the parametrization of y. So we have got our parametrization. I will frame the first step with some blue color. And now let's proceed to the second step. The second step will be to calculate line element. So we had formula that line element is equal to square root of derivative of x squared plus derivative of y squared times dt, since we are in two-dimensional space. Okay, let's calculate derivative of x. X is equal to minus 3t plus 3, and we will derive this, that is equal to minus 3, and derivative of y is equal to derivative of minus 4 times t plus 4, and that is equal to minus 4. So let's change this here. Minus 3 squared plus minus 4 squared times dt, which is equal to 9 plus 16 square root of 25 times dt, which is equal to 5 times dt. So we have calculated a line element. ds is equal to 5 times dt. So we can proceed to the third step, and third step will be to plug in all informations that we obtained from the first two steps. We have integral over the curve L of x plus y. Okay, and that will be equal to ordinary integral from 0 to 1, and x is equal to minus 3t plus 3 plus y is equal to, I will write here minus 4 times t plus 4 times line element is 5 dt. So this is equal to integral from 0 to 1 minus 7 times t plus 7, and we multiply that with 5 dt's, and using linearity and everything, we have integral from 0 to 1 minus 35 times t dt plus 7 times 5 is equal to 35 times dt. And using Newton-Leibniz formula, we have that this integral is equal to minus 35 t squared over 2 from 0 to 1 plus 35 times t from 0 to 1. So let's just change this. Let's just plug in what we have to plug in. 1/2 minus 0 plus 35 times 1 minus 0, which is equal to minus 35 halves plus 35, which is equal to 35 halves. So we have got the same result as in the previous video. which confirms the theory that the starting point isn't important. We can start from any point we want. It is best to start from some point at the end of this straight line, A or B. It isn't very practical to start from some midpoint, C, and go to the point B, and from C go to the point A. That is not practical. It is best to start from some of these 2 points, A or B, when we want to integrate, but we can choose the point. We can start from the point A and go to the point B, just like as in the previous video, and we can start from the point B and go to the point A, which will be the last point. As in this video, we will get the same result. So the conclusion is that integration doesn't depend on the way we go. Okay, nice. That was all from this video. See ya in next video. Bye bye.